To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Again, I'm going to continue with the extra questions in electrochemistry. So this is extra question 10. What are the conventions adopted in electrolysis? So to write that, what I will do is I will draw an electrolytic cell, then we will write down the conventions. If you all remember the conventions, you can do that directly, but it is better if we understand and recall what we discussed before. So here, when you have an electrolytic cell, you have the electrolyte solution there, then the two electrodes, and they are connected to the power supply. So here it is the electrolyte. Now since this is the positive terminal and that's the negative terminal of the batteries, the power supply, the electrode that is connected to the positive terminal becomes the positive electrode and this becomes the negative electrode. At the same time, you all know students, in the electrolyte solution, there are positive and negative ions, X plus and Y minus. I will write it that way. Then what happens there? The positive ions migrate towards the negative electrode, while the negative ions migrate towards the positive electrode. And near the positive electrode, there is going to be oxidation. And where oxidation occurs is the anode. And near the negative electrode, the positive ions or the cations migrate towards the negative electrode. There they take up electrons from the electrode and get reduced. So here it is reduction. And because reduction occurs at the negative electrode, we call it the cathode. So this is the positive electrode where oxidation happens and it is the anode. Negative electrode where the reduction occurs, it is the cathode. And also, you all can remember, some of the electrolytes, there are more than one cations. Then what happens? Out of the cations that are present in the cell, the least reactive one or the metal that is below in the lower in the activity series has a higher chance of getting reduced. So that will undergo reduction there. And also, if there are more than one anions, the negative ions, there of course there are different factors that determine which undergoes oxidation. But you all have to remember what happens there. And also, we can have a metal as the positive electrode there. Then of course, the ions do not undergo oxidation. Instead, the metal electrode itself undergoes oxidation. So those are the conventions adopted in electrolysis. Now that we have recalled everything, we can write them down here. So first one we can say electrode connected to the positive terminal of the power supply becomes the positive electrode and the electrode connected to the negative terminal of the power source is the negative electrode. Then what happens? The positive ions or the cations move towards the negative electrode in the electrolyte solution. While we have written the positive ions, negative ions, that is anions from the electrolyte solution. Solution moves towards the positive electrode. Then what happens? The positive cations take up electrons from the negative electrode and get reduced, or we can say undergo reduction. Because reduction occurs at the negative electrode, it is the cathode. And also what happens there? When there are more than one positive ions in the solution, then the metal that is lower in the activity series has higher chance of getting reduced. For example, you can consider the electrolysis of aqueous sodium chloride. So when we say sodium chloride aqueous, there will be Na plus ions and H plus ions. Both are cations. But Na plus is more reactive than H plus. So H plus is lower in the activity series. So therefore H plus gets reduced. Then H plus, 2 H plus ions take up 2 electrons, getting reduced to H2 gas. So that is what happens there. H plus is reduced. Another example you can consider. If it is copper sulfate aqueous, there will be Cu2 plus aqueous and again H plus aqueous. Now, out of these two, copper is lower in the activity series. It is less reactive compared to H+. So, copper will undergo reduction. So, here of course, Cu2 plus aqueous takes up 2 electrons and become Cu solid that deposits at the cathode. I'm sure you all can remember all these when we discussed and did the activities related to electrolysis. The same way, now already I told you all, the negative ions move towards the positive electrode. So there what happens? The negative, that is the anions, get oxidized at the positive electrode by losing electrons. Losing electrons. Because oxidation takes place at the positive electrode, it is the anode. Positive electrode is the anode. And they are also, when there are more than one anions, one of them gets oxidized. But here, of course, we don't discuss the factors that affect or determine which ion gets oxidized. For example, you can remember if it is NaCl aqueous, there are Cl minus ions and OH minus ions. Here, of course, the Cl minus ions, 2 Cl minus ions become Cl2 gas by losing 2 electrons. That is the oxidation that takes place. So, you all can remember that as well. Then, if you take the last one, like I told you all, when there is a metal as the anode, instead of carbon electrode, if there is a metal connected to the positive terminal of the power supply, then that metal gets oxidized. For example, if we have silver rod as the positive electrode, then Ag solid becomes Ag plus aqueous by losing an electron. It undergoes oxidation. Is that clear, students? So, these are the conventions that are adapted during electrolysis. If I quickly go back and go through the conventions, So here I showed you all the electrolytic cell. When you connect the positive terminal, this becomes the positive electrode, this becomes the negative electrode. The negative ions move towards the positive electrode, there they get oxidized and therefore it is the anode. And here near the negative electrode, it is the positive ions, cations. They undergo reduction, taking up electrons from the negative electrode. So because of that, that becomes the cathode. So then, if we look at the conventions, electrode connected to the positive terminal of the power supply becomes the positive electrode, and the electrode connected to the negative terminal of the power source is the negative electrode. So power supply, power source, those are similar terms you can use. The positive ions, that is the cations, move towards the negative electrode in the electrolyte solution. You can say in the electrolyte solution, or you can say from the electrolyte solution. While negative ions from the electrolyte solution moves towards the positive electrode. So opposite charges attract. Then the positive cations take up electrons from the negative electrode and get reduced. Because reduction occurs at the negative electrode, it is the cathode. Then the next one. When there are more than one positive ions in the solution, then the metal that is lower in the activity series has higher chance of getting reduced. As examples, we looked at two examples. When we electrolyze sodium chloride aqueous, there is Na plus aqueous and H plus aqueous. Out of those, H plus aqueous, because that is lower in the activity series, is less reactive than sodium, that undergoes reduction. H plus ions get reduced to H2 gas. At the same time, when we look at hydrolysis of copper sulfate solution, then there are copper 2 plus ions and H plus ions. But there, of course, H plus is more reactive than copper. Copper is lower in the activity series. So that undergoes reduction. Cu2 plus takes up 2 electrons, depositing as copper solid at the cathode. Then, the negative anions get oxidized at the positive electrode by losing electrons. So, because oxidation takes place at the positive electrodes, it is the anode. And when there are more than one anions, one of them gets oxidized. But the factors that affect this are not discussed. So, as an example, I have given this. When there is the electrolysis of sodium chloride solution, Cl minus aqueous and OH minus aqueous are there. There it is Cl minus aqueous that gets oxidized. So, here Cl minus aqueous gets oxidized to Cl2 gas, releasing 2 electrons. Then, finally, instead of carbon electrode, if there is a metal connected to the positive terminal of the power supply, then what happens? Instead of a negative ion getting oxidized, that metal gets oxidized. Example, silver rod as the positive electrode, then silver solid becomes silver plus aqueous, losing an electron. That is the oxidation process taking place there. So, these are the conventions adopted during electrolysis. I am sure you all can remember all those, students. And I have explained them before also. Now also I explain them to you all. I am sure you all also have written the correct conventions. So, with that, I will move on to the next slide. Extra question 11. Electrolysis of fused sodium chloride using carbon electrodes is shown in the diagram below. So, if we look at the diagram, so here you can see the power supply is there. So, positive terminal is connected to this carbon electrode, that becomes positive. Then the negative terminal is connected to this carbon electrode, so that becomes the negative electrode. And since it is fused sodium chloride, there are only sodium ions and chloride ions. Na plus liquid and Cl minus liquid. So here you can see Cl minus liquid moves towards the positive electrode, Na plus moves towards the negative electrode, and their oxidation and reductions occur in the respective electrodes. So to answer the question, first one, write the reaction occurring at the negative electrode. So towards the negative electrode, it is Na plus liquid. So Na plus liquid takes up electron, forming Na liquid, sodium liquid. Reduction of sodium ions to sodium metal. Write the reaction occurring at the positive electrode. Near the positive electrodes, what happens? It is Cl minus liquid. So there Cl minus liquid forms Cl2 gas. So to give Cl2 gas, we need 2 Cl minus liquid, gives rise to Cl2 gas, losing 2 electrons. That is the reduction reaction occurring at the positive terminal. Then we have the next one. Write the products of electrolysis of fused sodium chloride. So sodium liquid is formed at the negative electrode, while chlorine gas is evolved at the positive electrode. Sodium liquid is the main product, chlorine gas is the byproduct. So sodium metal, that is Na liquid, is the main product. That is in the industry I am saying. So this, of course, you can write it within brackets, main product and chlorine gas. That is Cl2 gas. That is the byproduct. In the industrial extraction of sodium, sodium liquid is the main product, chlorine gas is the byproduct. But here write the products of electrolysis of fused sodium chloride. You can just directly write it as sodium metal and chlorine gas. That is more than enough. This is the additional information that I have given to you. Is that clear, students? So then we'll move on to the next slide. Extra question 12. Electrolysis of aqueous sodium chloride using carbon electrodes is shown in the diagram below. Electrolysis of aqueous sodium chloride using carbon electrodes is shown in the diagram below. So here also you can see the positive and the negative terminals. So the electrode connected to the positive terminal becomes the positive electrode. The electrode connected to the negative terminal becomes the negative electrode. And since it is aqueous sodium chloride, you can see here Na plus, Cl minus, H plus and OH minus all are there. Both Na plus and H plus migrate towards the negative electrode. Cl minus and OH minus move towards the positive electrode. But you all can see the products are shown there. At the positive electrode, chlorine gets oxidized. Cl minus chloride ions get oxidized, forming chlorine gas. At the negative electrode, it is the H plus ions that get reduced and become hydrogen gas. So this is sodium chloride aqueous. That is the electrolyte. And here we have carbon electrodes. This is also carbon electrode. So that is what you need to know from this particular electrolytic cell. Then what are the ions present in the solution? It is shown to you in the diagram. You need to write them. Na plus aqueous, Cl minus aqueous, H plus aqueous and OH minus aqueous. Then Write the ions that migrate towards the anode. Towards the anode, what are they? Those are the anode is where the oxidation takes place. That is the positive electrode. So it is Cl minus ions and OH minus ions. Write the ions that migrate towards the cathode. Cathode is where reduction takes place. So that is the negative electrode. Towards that, it is Na plus aqueous and H plus aqueous. So although the ions are shown in the diagram, you all have to select and write the correct ions. So all the ions present in the solution, Na plus, Cl minus, H plus and OH minus. Out of those, the ions that migrate towards the anode where the oxidation takes place are the negative ions, Cl minus and OH minus. Write the ions that migrate towards the cathode, that is where the reduction takes place. That is the negative electrode. So it is the positive ions, Na plus and H plus. So you have to remember all these things today. Then only you can answer any type of question given to you. With that, I am going to move on to the next question. Then we have the fourth part of the reaction occurring near the anode. Write the reaction occurring near the anode. Now already students, I have labeled all these to you all. These are carbon electrodes and this is NaCl aqueous. Write the reaction occurring near the anode. Anode is where oxidation takes place. Now here you can see Cl2 gas is evolved. So that is 2Cl minus aqueous becoming Cl2 gas, losing 2 electrons. That is the oxidation taking place near the anode. Write the reaction occurring near the cathode. Cathode you can see here, hydrogen gas is liberated there. So that means 2H plus aqueous takes up 2 electrons, giving rise to H2 gas. That is the reduction taking place near the cathode. Why do hydrogen ions get reduced and sodium ions don't get reduced? What is the reason? Because hydrogen is less reactive than sodium and it is present lower in the activity series. So here you can say because hydrogen ions are lower in the activity series when compared to the more reactive sodium ions, that is Na plus. So because hydrogen ions, that is H plus, are lower in the activity series when compared to the more reactive sodium ions. That is why hydrogen gets reduced and sodium does not get reduced. Is that okay, student? So then I'll move on to the next slide. Question number 7. Write the observations of the activity. What are the observations? You can see liberation of gas near the positive electrode, liberation of gas near the negative electrode. Liberation of gas bubbles. So if it is Cl2 near the positive electrode, then liberation of gas bubbles that is H2 near the negative electrode. So here you are supposed to write the products formed during the electrolysis of aqueous sodium chloride. What are the products? Chlorine gas, hydrogen gas. Is that all? No. There will be sodium hydroxide remaining in the electrolytic cell. So sodium hydroxide, that is there in the electrolytic cell. Is that okay, students? So chlorine gas, hydrogen gas and sodium hydroxide. So I'm sure you all would have answered all these questions correctly. So with that, I will move on to the next question. Extra question 30. An activity carried out to electrolyze an aqueous copper sulfate solution using carbon electrodes is shown in the figure given below. So it is the electrolysis of aqueous copper sulfate solution. So you can see here the positive terminal, the positive electrode, that is the anode, carbon, and the negative terminal, that is the carbon electrode, that is the cathode, an aqueous copper sulfate solution. So here what are the ions present there? Cu2 plus, SO4 minus, and H plus and OH minus. Now after these you all know Cu2 plus will get reduced and OH minus will get oxidized. That is how the ions get reduced and oxidized. So if you are to answer the questions, write the cathodic half reaction. Cathode means it has to be the reduction. So it is copper ions that will get reduced. So if we write the cathodic half reaction, Cu2 plus aqueous takes up 2 electrons forming copper solid. That is the cathodic half reaction. Write the anodic half reaction. OH minus is the ion that gets oxidized. So there what happens? For OH minus aqueous becomes 2H2O liquid plus O2 gas, losing 4 electrons. That is the oxidation reaction, which is the anodic half reaction. I'm sure you all can write those today. So with that, I'll move on to the next slide. Part 3, write 2 observations of the above activity. Now you all know copper deposits at the negative electrode. So that is 1. Copper deposits at the negative electrode. Then what did we write? We saw that OH minus ions get oxidized. So oxygen gas bubbles are liberated at the positive electrode. So gas bubbles are liberated at the gas bubbles are liberated at the positive electrode. What is the other observation? Now when copper ions deposit, they are taken from the solution. Cu2 plus ions from the solution deposit as copper. So because of that, blue color of the solution gradually decreases. So that also happens here. I'm not writing that as an answer. I will just mention it here. So blue color of solution decreases gradually. That is also an observation. So you can write any two of the observations. Then, the next question. Briefly explain the above observation. So, if you are to explain the above observations. Now, copper deposits at the negative electrode. Why? Copper deposits at the negative electrode because Cu2 plus ions have higher tendency to get reduced compared to H plus ions. That is one explanation. We have already written the reduction reaction, so we don't need to rewrite it again. At the same time, there are sulfate ions and OH minus ions. So here, OH minus ions from the solution get oxidized while sulfate ions remain in the solution. So here, of course, we don't explain why sulfate does not get oxidized. That is something you all have to remember. Then, these are the two observations I wrote as the answer. But I told you all the blue color decreases. Now, if you wrote that as the answer, then what will you all write? So, as a note, I will write it here. Blue color of the solution decreases gradually because Cu2 plus ions from the copper sulfate solution get reduced at the cathode. That is the reason why the blue color of the solution decreases gradually. So, if you wrote that as the observation, you will have to write this explanation. Otherwise, we can stick to the two previous reasons. Briefly explain the above observations. Copper deposits at the negative electrode because copper ions have higher tendency to get reduced compared to H plus ions. At the same time, OH minus ions from the solution get oxidized while SO4, that is sulfate ions, remain in the solution. And as a note, I have given this blue color of the solution decreases gradually because Cu2 plus ions from the copper sulfate solution get reduced at the cathode. So, you all also can write a similar explanation. With that, students, I'll move on to the next slide. That is extra question 14. An activity of electrolysis of acidulated water using carbon electrodes is shown in the figure given below. So, when we have acidulated water, electrolysis of acidulated water, you can remember, students, the particular electrolytic cell is somewhat different from the other electrolytic cells. Why? Because we need to collect the gases evolved or liberated at the two electrodes. So what do? We use a plastic cup. Here you can see plastic cup. Inside that we take the acidulated water. What do there? We add dilute sulfuric acid, a small amount, to distilled water to get acidulated water. Then to the plastic cup, before we take water in it, what we do is there are two holes made and the carbon rods are inserted into the plastic cup, and then it is sealed either with silicone gel or wax in order to make sure that the water does not leak, or even PVC. So we seal it, and then they are connected to an electric source, that is a 9-volt battery. And then only we take water, acidulated water. At the same time, we fill 2 test tubes completely with water and invert them over the 2 electrodes. And when the cell is functioning, you will see the water will be displaced downwards and the gases will collect over the 2 inside the 2 test tubes over water. And also you will see a difference between the amount of gases collected there. Here you can see near the positive terminal, less volume. Near the negative terminal, there is more volume of gas collected. And you all know it is hydrogen gas that is collected here, and here it is oxygen gas. So that is how the electrolysis of acidulated water using carbon electrode occurs. So then, if we look at the questions, what are the ions present in the electrolyte? What are they? There will be H plus ions, OH minus ions, and from sulfuric acid there will be sulfate ions, and already I have written H plus ions there. So 3 ions. You don't have to repeat H plus here. These are the 3 ions present in the electrolyte: H plus, OH minus, and sulfate. Write the ions that migrate towards the cathode. Cathode is where reduction occurs. So cathode is the negative terminal. So it is only H plus ions from water and acid that migrate towards the cathode. So it is H plus aqueous, or we can say H plus ions, or you can say H plus ions. You can write the answer in any way. Then I'll move on to the next slide where we discuss the rest of the questions. Third part, write the ions that migrate towards the anode. Anode is the positive electrode, so the negative ions, the N ions, migrate towards it. That is OH minus ions and SO4 2 minus ions, that is sulfate ions. You can write it as hydroxyl ions and sulfate ions also. If you want to write the name, hydroxide ions and sulfate ions. That way also you can write. So part 4, write the balanced ionic equation for the reaction that occurs at the cathode. So the reaction that is occurring at the cathode, it is the reduction. So here it is the H plus ions that get reduced, plus 2 electrons give rise to H2 gas. So 2 H plus aqueous plus 2 electrons giving H2 gas. That is the reaction occurring at the cathode, reduction reaction. So these are the answers to these questions, students. But the question continues in the next slide also. So part 5, write the balanced ionic equation for the reaction that occurs at the anode. At the anode, it is OH minus ions that gets oxidized. So 4 OH minus ions become 2 H2O liquid plus O2 gas, losing 4 electrons. So that is the reaction occurring at the anode, oxidation reaction. Write 2 observations of the above activity. Now, like I told you all students, here you can see there are 4 electrons in the previous one. When we wrote the reduction of H plus ions, there were only 2 electrons. In order to balance the electrons, we multiply the previous reaction by 2. So, therefore, as a result, when the gases are liberated, there will be 1 volume of oxygen liberated at the positive electrode, that is the anode, while there will be 2 volumes of hydrogen gas liberated at the negative cathode. That is what you can see there. So, that is also an observation. So, here what I will do is, I will write the first observation as gases are liberated at the anode and cathode. Then 1 volume of gas is liberated at the positive anode, that is O2 gas, while 2 volume of gas is liberated at the negative cathode, that is H2 gas. So, those are the observations. Gases are liberated at the anode and cathode. 1 volume of gas is liberated at the positive anode, that is O2 gas. So, here this is anode, while 2 volumes of gas is liberated at the negative cathode, that is hydrogen gas. So, I have included both the observation here. 2 observations, I have included them there. You can also write gas bubbles are liberated at the anode, gas bubbles are liberated at the cathode, but I just wanted to include everything, so I have combined them as one observation, and the second one I have compared the volume, because that is a specific observation for this particular activity. You have seen that in the lab also. So, you all can remember the observation. So, with that students, I will move on to the next slide. So, here we have extra question 15. Write 4 applications of electrolysis. 4 applications of electrolysis. Can you all remember those? It is used to extract metals. For example, extraction of sodium from fused sodium chloride. Extraction of aluminium from bauxite. So, that is one application. Then, industrial manufacture of caustic soda, that is sodium hydroxide. So, there we use a diaphragm cell method. Extraction of sodium is down cell method. Then there is the process of electroplating. That is also an application of electrolysis. So, like that we can use different examples. We need to write 4 examples there. So, here first one I can say extraction of metals like sodium and aluminium. We don't need to give more detail, but you all are familiar with the process. Sodium, you can remember the down cell method where we use fused sodium chloride to extract sodium metal. And you all know to extract aluminium, bauxite is used. That is the mineral that contains aluminium, and aluminium is extracted from bauxite. Then I said the industrial manufacture of caustic soda. Caustic soda. That is what? NaOH. And this, of course, is known as the diaphragm cell method. So here we electrolyze sodium chloride aqueous. So from there sodium hydroxide is produced. Then the third one, electroplating. Plating. So there, as examples, we have looked at electroplating of iron or steel objects with tin or nickel. These are different examples. You all can write any example there. So there are 3 applications I have written. We are supposed to write 4 applications. There is one more application. What is that? Refining of metals. The last one, I can write it as metal refining. What is metal refining? When you extract a metal from its ore, sometimes there can be impurities present in it. Removal of those impurities from the metal ore is what we call as metal refining. So that is also an application of electrolysis. Extraction of metals like sodium and aluminium. Industrial manufacture of caustic soda, that is NaOH, diaphragm cell method. Then electroplating, example electroplating of iron or steel objects with tin or nickel. Then even gold plating, copper plating, anything you can give as examples. And metal refining. There are also, if you like, you can write the example. When copper is extracted as the metal, the impurities need to be removed. There, electrolysis is used to remove the impurities. That is refining of copper. So like that, you can write the 4 applications of electrolysis. I am sure you all have done that correctly. So with that, students, I am going to end this chapter, and in the next chapter also, I will discuss some more extra questions with you.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.